So, quick video on the functions thing. I'm just picking a couple of types of problems that historically I've seen people have some issues with. So, thought maybe a little extra help might be in order. Okay, so before I get onto that though, one little note, because it's just kind of an easy thing to overlook, and I've seen lots and lots of people kind of misunderstand a little bit. But the function notation thing, when we have something like f of 2, in this case I've got f of x is negative 2x squared, all that little 2 says is substitute that in for x. This is not multiplication. Okay, so when you substitute that in, all you're going to do is just evaluate the expression that's on that right-hand side. Okay. Now, when you make the substitution, please use parentheses, because if you don't, you will probably get the answer wrong, especially with these negative numbers with quadratics and exponents and things like that, because here we'd get negative 2 plus 32 minus 37, negative 5. So that'd be something like a negative 7, I guess. But what I see a lot of people doing is they get to this point and then they're like, oh, look, it's f times 2. And then they try to divide by 2 for some reason. And that is not what should happen. Okay? So remember, that's not multiplication. Once you simplify and you get that negative 7, that's all that it is, right? Okay, but on to actually what I wanted to make the video about, and that was rewrite this thing to find the vertex. Okay, so the vertex for a parabola is the higher the low point. It's where the bottom of the U is or the top of the hill. And every quadratic function can be rewritten to look something like this. Okay, now the trick to doing that, in order to rewrite it in this form, the first thing that you're going to do is you're going to take a look at the variable terms. Okay, and whatever the coefficient is for x squared, you're going to factor that out of those two terms. It does not matter if you wind up with fractions or not. It's not like we're finding a greatest common factor, okay? So it's just, we're going to divide out whatever the coefficient for x squared is. And when we do that in this case, in the parentheses, we're going to be left with an x squared plus a 16x. Now, we still have that minus 37 hanging out here at the end. Now, the next step, and this is the tricky one, is you take the linear term, the one that has just the x, and you take half of that. And that's going to be 8 in this case. Then you're going to square that number. So that's going to give me 64. You're going to add that in the parentheses. So on the next step, we're going to find that number. We took half of the 16, we squared it, and we're going to add that in our parentheses. Now, we all know you can't just start adding numbers. Okay? That's not allowed. So the trickiest part of this is I didn't add 64. Okay? What I actually added was a 2 times a 64, because you got to think we would be using the distributive property if we're trying to simplify it, right? So really what I put into my equation here is a negative 128. Now, I have to balance that out because the only number that we can add is 0, right? So if I put a negative 128 there, then by the same token, I have to do the opposite of that out here somewhere. Okay. All right, so since we put the 64 in parentheses, really we had the 64 times negative 2, so that's the negative 128. That's why I put a plus 128 out there. Now, the whole reason for picking this number is that we've created a perfect square trinomial, and I know that's going to factor, and you take the square roots of the 64, and you're going to have an x plus 8. Now, if you have a minus sign here, that sign would match. Okay? And then the last thing we'll do is say, okay, well, what's the negative 37 plus 128? We'll combine those like terms and get a plus 91. And then we have a little squared here I forgot to write down. So you factor out whatever the coefficient is for x squared. Then on the term that just has the x, you take half of it and square that, and you add that into the parentheses. And it's always adding. Okay? Now, if you had to factor something out, then take the number you added in and multiply it by that factor, and you're going to do the opposite of that. So if you had a negative, you're going to do a plus. If that were a positive 128, we would have subtracted. We have to balance it. Okay? And then we just factor that trinomial, and that gets us in the right form. So what this tells me is that the vertex is at negative 8, because it's always the opposite of what is in their parentheses with the x, and the y-coordinate is 91. It's always the constant term out at the end. Like I said, it doesn't have to be whole numbers and stuff like that. Let's just make up another one here. Okay. And then get rid of all this, because I really didn't kind of plan out very well, or I would have already had one typed out. So let's say that we have f of x equals 3x squared plus 2x minus 1. And I want to know where the vertex is, and I want to write it in that vertex form. First thing is to factor out the 3. So that's going to be an x squared plus 2/3 x minus the 1. So when I divide that 3, remember, you're dividing these things by 3, and that's where that 2/3 comes from. So when you pull that out in front of parentheses, you're dividing. So 3 divided by 3 is 1. 2/3 divided by 2 divided by 3 is just 2/3. Okay. Now we're going to take half of the 2/3 and square that. So what is 1/2 of 2/3? That is 1/3. And then we do 1/3 squared is 1/9. So we're going to add 1/9 here. Now I'm adding that 1/9, but keep in mind it's 1/9 times 3 if I kind of distribute stuff. So over here with my scratch work, if we do 1/9 times 3, that will be 1/3. So since that's a positive there, I'm going to subtract 1/3 out here. So that's 3, and that's x plus, and we're putting the square roots in here. We already know the square root of 1/9 is 1/3, because that's how we found it. And then we have to do 1 minus 1/3. So let's see, getting a common denominator. So that would be a negative 4/3. So that's what goes out at the end here, a minus 4/3. And then my vertex is negative 1/3, comma, oh, that's supposed to have been a 3 there, negative 4/3. Okay. So that's how I can rewrite this in vertex form. It can be a little bit tricky. A little bit of practice though, and I'm sure you'll get it. Now the next little thing was just a quick word problem. So we have a vehicle factory that manufactures cars. The unit cost, the cost in dollars to make each car, depends on the number of cars made. If X cars are made, so that's what our variable stands for, right? X is the number of cars that we make. Then the unit cost is given by this formula. So that's the other important part here. We got this little formula. How many can be made to minimize the cost? So we want is the least amount of cost possible. Now, on any parabola, you know, it's going to look like this. I don't know. I mean, it might be shifted up or down or something like that, but, you know, the quadratics are all parabolas. Okay, and since that leading coefficient is positive, I know it opens up. That's about all I know about the graph right off the top of my head. But what I'm looking for, the minimum, is the vertex. Okay, now if you're asked to find a maximum, well, that's also a vertex. That just means your parabola is turned upside down and you got a hill instead of a valley. So I want to find the vertex, and it asked how many. So I'm looking for the x-coordinate of that vertex. Now we have a nice little formula that says the x-coordinate of the vertex is negative b over 2a. So I'm going to use that instead of trying to rewrite it in vertex formula, with vertex form like we did a second ago. So the opposite of b, which would be a positive 228, over 2 times a, which is the 0.6. Okay, so that's 228 divided by, and that would be 190. So we need 190 cars. So anytime that you're minimizing or maximizing and you have a quadratic, okay, then you're just looking for the vertex. Just be careful if you have to find the x or the y coordinate. Here it said how many cars, so I'm looking for the x coordinate. If it asked for what the minimum cost is, then we have to substitute that in to find out what the y coordinate of the vertex is. All right, I hope this helps a bit, and please let me know if you have any questions.